So this is a conceptual example number 1, which means maybe some math to it. What do we want to say about this? Let me just set this up. Okay, so example 1. I got to give you a little bit of background. What this is called the Gaussian distribution. It measures how often something happens based on what value is. If I know the value here, I know what percent of the time it's going to happen there. And it turns out that if I add out all these probabilities, I get 100% probability. So it's got to happen there. Now, there's some things you need to know about the Gaussian distribution. Let me see, I've got to rearrange this again. Here we go. Is that between, this is called the mean, or the middle, and then you have what are called standard deviations. We use the symbol sigma, short for standard deviation, or standard mean, depending on how you set this up. A standard deviation, I know you can't read that, but just like you can listen to it. And it turns out that the probability of something happening between the mean plus one of the deviation and minus the deviation is about 2/3. 66% or so, 67% of the chance that if we take a sample and get this distribution, that if I choose, if I measure something randomly, 2/3 of a chance it's between one standard deviation. So they say, oh, so we're going to say the mean is 5 plus and minus one standard deviation of 2. And I just made that up completely. This would have something that looked like this. So 5's in the middle, minus 2 is 3 there, and plus 2 is going to be 7. So 2/3 of a chance the number I choose, or a random number chosen from this distribution, will be between 3 and 7. Now, it's also true that outside 2 standard deviations, see there are 2 standard deviations, that if you have the mean plus and minus 2 standard deviations, it's actually like 95% chance. Whereas one standard deviation is 2/3, 2 standard deviations is 95%. So almost all the numbers that you'd actually take randomly will fall in that. Now, we've got to look at this example here. So they want to know, is this diamond, what do? You lent someone a diamond. Can you believe it? Right? And you read it was on a scale that read 8.17. Okay, so let's kind of draw a picture here for what's going on. So we've got an average of 8.17, and the error on the scale is 0.05. So if we add that to that, this goes to 8.22. And if I subtract, let's see if I can do this math in my head, 8.12. So I get that right? So it's 8. So this is plus, that's plus 0.05. This is minus 0.05. So we know that 2/3 of the time it should be within this range of values. Now, this is not a stats course. This is kind of the level I need you to go. And then they return the diamond to you, and it weighs 8.09 grams. Well, 8.09 is down here. There's only 1/3 of a chance that the diamond is the same. But if we take the 2 standard deviations, like it's 8.07 and 8.27, we know that 95% of the time it falls in this range. Yeah, it does fall in that range. Didn't fall exactly in here. So what the simple-minded approach we want for this is, for this question here, is 809 within the standard deviation of 8.17, with that being the standard deviation? No, it's not. We suspect that our friend has swapped out the diamond. That's what we want to know.